question 10, and this one states, for any vectors u, v, and w in v3, or the set of all points in 3 dimensions, we have this statement, u plus v cross w equals to u cross w plus v cross w. Basically, can we multiply this or do this vector of each of these numbers or vectors that we're adding separately? So the vector of these added together is equal to the vector, the cross product of each of the vectors separately. So that is interesting, and this is actually true as well. Again, it's very similar to question 9. I went over this to show you it. This one's going to be a bit more, it will take too long to go over it all, so you have to watch my earlier video on that. But I will provide a quick overview of why this is the case. So again, this is true. This is true and is another property of the cross product, again, from my earlier video right here. So if you have A cross B plus C, you could just take the cross product of each separately and add them up. So it's the same thing as this, plus this one right here. Yeah, plus this cross product, like that. And that's just these right there. So that's the same thing there. And we can see this, why this is the case, and I'll just do more high-level stuff here. So if we go back here, so u plus v cross w. So what we have is, so if we have this right here, u vector plus v, now we do the cross product with w, and put this in the cross product. This equals to the determinant form I, j, then k, like that. So now what we're going to end up having is, well, u plus v, so all the components are now added together, so we're going to have a u1 plus v1, and then we're going to have a u2 plus v2, and yeah, we're going to need more space. Yeah, so here's added, just separated more, so this is going to be now u2 plus v2, and then this is going to be u3 plus v3, and this is going to be for w1, w2, and then w3. And now, instead of evaluating like we did in the earlier example, what we'll do is just you can see that this is the case, because when we use our setup like this, where we would cross this out, so we're going to multiply for the first I term, or the x components, multiply this by this, and then we put a minus sign and subtract this right here, u3 plus v3 times w2, like that. But we have this right here. So in other words, each time we're multiplying this u2 plus v2 with w3. So in other words, we could multiply this by itself, and then this afterwards when we expand it out. And for every single time we do this, multiply this one and then this again. So we're doing pretty much a cross product twice. So this is literally, we're doing cross product twice, but we're adding those up. So in other words, instead of so we can just ignore all this one. So if you can ignore this. Whoops, let's say, yeah, if we can ignore this side right here. And also, I just realized my OneNote, if I scribble like that, it just automatically deletes. So that's interesting. So I'll just do this right here. So if we cross this out, and then take the cross product, we get exactly what we would do just with this u there. We'll have u cross w. And then we'll just then afterwards we'll just assume it's over there, and we add them all up. So in other words, this just equals to, I'll make this a big, we'll write this out bigger right here. Yeah, so this equals to the same thing as writing I, like this is the I component, like this. And this is going to be the same thing as writing u, w1, and then this next one's u2. So we can just ignore all the v's, u2, w2, and this is the j component, and the k component. It's going to be u3, w3, and then add up. Now we ignore all the u terms and do the other side there. So it's the same thing as writing that. This is going to be v1, v2, v3, j, k, w1, w2, w3. Yeah. So in other words, this is just a cross product of separately. So this is going to be u cross w. Now this is going to be plus v cross w, like that. Yes, this is exactly what we had. And again, I didn't want to evaluate all; it will take too long, and I've done it already. And again, you could just see that this is the case because you're doing the exact same thing, but then there's an addition every single time. U1 plus V1 times W2, etc. Then minus U2 plus V2 times this one. So in other words, just do it separately and then add them up. So that is this. Then we will get this and this one right here. So that's true. All right, so now let's take a look at question 11. So for any vectors u, v, and w in V3 or the set of all points in 3 dimensions. Now we're given, so we have u dot and then v cross w, and these are in bracket. They're saying that this is equal to, right here, bracket u cross v dot w. So in other words, this is just the the scalar triple product. Because when you have a dot product with a vector and a cross product gives a vector, but then you dot product, you get a scalar. And they're basically saying that you could you could do the scalar triple product where you have the first vector dot with the cross product of the rest, or cross product of the first two and then dot product with the other one. And in fact, this is true. This statement is actually true. This is just a property of the scalar triple product from my earlier video here that I went over the proof there, like that. And I think I might as well just go over it as well here, just in a quicker method that I found that I just did, or that I will do than I did in this one here. Just a slightly different method, but I just want to go over it because it's a pretty good review. So we can see that this is the case, and let's just do the scalar triple product. So let's say we have u, v, w. So u dot v cross w. So the scalar triple product, instead of using our ij components, we could write this out all in one go. We can go u1, because we're going to be multiplying out, instead of multiplying by the components, by the ij and k vector components, or the unit vectors, or whatever they're called, we can go straight up with the vector u. And then multiply those out, it becomes a scalar. So the next one's going to be v1, v2, v3. And then this is going to be w1, w2, w3. And now we just do the exact same thing, except now instead of multiplying by the ijk, we'll multiply by u. So we're going to go u1 multiplied by, now we're going to do the exact same thing, cross this out. So this times this, and then minus this times that. So in other words, we get right here, this is going to be now v2 times w3 minus v3 times w2. And then we just march forward to the next one like this. So now we cross this out, and we also put the u there. So now the second one. So this is going to be a minus now. u2, so now, remember the center one is always minus. So v1 times by w3 minus v3 times w1, like that. And I'll just move this over to the left so I have more room, right, all in one line. So now next one's plus, and erase this one. And now we cross out this one, put a u3 like that. Erase this better, u3. And now we have a v1 times w2 minus v2 w1, like that. Alright, so now we can just erase this and this. Alright, so we have this now. So now we can just multiply the u inside everywhere. So we'll have a u1 v2 w3 minus u1 v3 w2. Next one's going to be u2 v1 w3, and then minus u2 v3 w1, like that. And also made a mistake here. This is a negative times a negative. That's going to be positive. So this is going to be plus, like that. Next one's going to be plus u3 v1, I'll try to fit it all in one line, minus u3 v2 w1, like that. And now the next setup is, well, we're gonna, because we want it in this setup here, so this dot w, so let's get rid of the all the w stuff there. So what I'll do is, well, let's get rid of all the, make it exactly like this one here. So that's what the idea is, make it like this u there. So we're gonna get rid of the w1 there, and w1 is, where's w1? So there's this part right here, and this one right here. So we take those components, it's going to be u2 v3, so we're factoring out the w1, and then minus u3 v2. So that's this one here. So we're going to go, yeah, so that was that. So we take this one and factor out a w1. And now the next setup is we're going to have to minus, make the exact same thing as this one, w2, And that's going to be, well, we look at the W2, that's this one here, and this one here. But now we have to do a minus sign, so this is going to be the positive. So that's going to be U1 V3 minus, and this can be negative now, U3 V1, like that. Now the next setup is the W3. This equals to, well, this part right here, right, this neater, and this neater. And the next setup, where is W3? This one here. So this is going to be U1 V2 minus U2 V1, like that. Yeah, so if we look what we have here, this is exactly the same thing. This one's V1 W2, this V2 W1, this U2, and then this V1. So exactly, everything is identical, except we're just changing this W to a V. So instead of, and this V to a U. So instead of doing a cross product of V cross W, now we have a cross product U cross V. So in other words, we got this component there. And then we're taking a dot product. So in other words, this exactly equals to this part here. So go back to the scalar triple product. So this equals to, this goes like this. This is going to be W1, W2, W3. So it's exactly the same setup we're doing, just going in reverse. This is going to be now U1, U2, U3. This is going to be a V1, V2, V3. And this equals to, well, this is the same thing as writing W dot. So we're doing the dot product of U cross V. And we already know the, in the earlier question, the dot product, yeah, the dot product, you can reverse the term. So this is the same thing as writing. And again, I'll scroll down to which question that was. Yeah, actually, I believe it's question 5. So let's go all the way to question 5 right here. So recall question 5. So if you have U dot V, and this was true, U dot V equals to V dot U. So we could just reverse the dot product once. And remember, the cross product gives a vector. So we're doing, yeah, so if this gives a vector U, W cross this one is the same thing as writing U cross V dot W. All right, so just fix that up. So yeah, so basically this is exactly what we were asked, and that is true. Yeah, and I just want to go over the proof just for quickly using this setup there, the scalar triple product determinant format. And yeah, so U dot V cross W equals to U cross V dot W. Yes, epic stuff there. All right, and now let's take a look at question 12. And this one states, for any vectors U, V, and W in V3, or the set of all points in 3 dimensions, U cross bracket V cross W equals bracket U cross V and then cross W. So basically same thing as before, but now instead of having a dot product and having the scalar triple product, now we just have another cross product. So in other words, we get a vector. So we get this vector is called the vector triple product. So the solution to this, well, this is actually false. And the online website that I'm using for the solutions doesn't actually have this question, so I'll be doing the solution on my own right here. So this expression U cross and then bracket V cross W is known as a vector triple product. Here's my earlier video. Here's a thumbnail to it. And this is a formula that the identity that I proved in there is that A cross and then B cross C is equal to the A dot product C times B minus A dot B times C. And then yeah, there was we never went over this part here, but this is not true, and I'll go over an example on that. So let's see if the given statement is true for the following example. So let's say we have because all we needed was one example to show that it's not true in general. So we'll have, let's say 1 1 1, and let's say we have V is equal to, and let's just make another something like this. So I'm pretty much doing this all live, this solution, because there was no solution manual for this whole quiz, and online I didn't have all the questions. This one didn't have the answer to this one, and some of them were a bit off in the other ones. But anyways, here to correct some of them. So let's put a 0 1 0 there, and let's see what we get. All right, so now let's take a look at the left side. So let's solve this left side, then we'll solve the right side and see if we get the same answer. So U cross V cross W. So we'll have U cross and then bracket v cross w cross, and this is going to equal to u is going to be, I'll leave it like this, u cross like that. I mean a u vector there, and then now we're going to have this, write this in determinate form I j k like this, and this is going to be, the v is going to be 1 0 0, and then w is going to be 0 1 0. Alright, so now this equals 2. What I'll do is I'll write this, because we're going to have another cross product. I'll just put the u's in here, and then I'll put the solution of this one in the bottom vector, because we get a vector, and then we're doing a cross product that goes in the bottom, so we'll put the u now. And the reason I put this 1 1 1 is just so that these are just basic identity vectors, and this one here just a random vector sticking out. But at least this one's not an identity vector, so that there's less likely a chance for both of them to be equal. This is more random than this one here, because I actually tried it with just all identity vectors, and that statement is actually true for those. All right, so let's do something like this. So we're going to do another the determinate form of the cross product I j k, and now we're going to put the u is going to be 1 1 1. And now I'm going to do this. And the next setup is, well, we have u right here. Yeah, so now we just solve this cross product and put them in here. So we cross this out, and we're going to get 0 times 0, and then minus 0 times 1. So in other words, we just get a 0. And the next setup, now we cross this out. This times this is going to be, well, 1 times 0 minus 0 times 0, that's another 0. And now the next setup is last one. We cross out this one. Yeah, we cross that out, and what we end up getting is 1 times 1 is just 1, and then minus 0. So in other words, we get a 1. Like that, yeah. And also a side note right here, since these are identity vectors, this one is on the x component, this is on the j or the y component. Now the k is the z one. So in other words, that's actually true. This is going to be the v is going to be on the x axis, and then the w is going to be on the z axis. And now we have a this one is going to be this is this part right here, 0 1 1. I mean 0 0 1. That's just going to be this v cross w, and this is again right angles to that. And I'll just here, yeah, just fixed it up, just added the x, y, z components there. Yeah, so the axis right there, and that is what we get. So just put that note there. And then these are just unit vectors, just value 1 on each of the axis. So yeah, so this is perpendicular to it, and that is exactly what we get there, and that's a v cross w. All right, so now we have this. Now we just take the cross product again. So we're going to get equals 2. Yeah, this is going to equal 2. We'll cross this. This, we get 1 times 1 minus 0. This is going to be, well, yeah, 1 times 1 is just 1i. 1i. And now the next setup is we do this. So this 1 times 1, we have a minus right here for the middle part. 1 times 1 is just 1, minus 1 times 0 is just 1. So we have 1, and then, yeah, it's negative 1j, like that. And then the next one is this. Now we can cross this out. This is just 0. So like that's just it right there. Yeah, 0k, like that. So we'll just leave it like that, or just put right as a vector form. We get 1, negative 1, and 0, like that. So that's what we have. And now we do the other way and see what we get. We use the right side, and so that's this is the left side. Now we do the right side, is we do the first one in bracket, and then the cross product of the one after. So we go we'll go u cross v cross w, like that. And now this one's going to equal 2. This is going to be the u. This is going to be our component I, j, k. And then the u is going to be just 1, 1, 1. And now the next one is going to be 1, 0, 0, 1, yeah, 1, 0, 0. All right, so that's what we get there. But now it's going to be cross with w. Cross w, like that. And all right, so that's w. Now the next setup, put this all in its own in its own indeterminate form, and then I do the solution there. And this one's going to be on the top row. This one's the second row, the bottom row. And that's the W is just, again, 0, 1, 0. So we get 0, 1, 0. Put the I, that is the I, J, K, like that. And this is going to be now, put this, solve this there. So cross this out. 1 times 0 minus 1 times 0 is going to be 0. And then the next one is right here. Cross this out. So we're going to go 1 times 0, and then this is going to be, but we have a negative here. So negative 1 times 0 is going to be 0 minus 1 times 1. So it's going to be a negative 1. So negative minus negative 1. So that's going to be plus 1. And now the next setup is the K one. So we would cross this out. 1 times 0 is 0. 1 times minus 1 times 1. So it's going to be negative 1 like that. And now just solve this out. This equals 2. Again, now we do the same thing over here. So cross this out. This is going to be plus 1. Yeah, 1 times 0, and then minus negative 1 times 1. So it's a negative, and that's positive. Yeah, so it's going to be equals 2. And I'll just do it. I'll do this straight up, going over to the write it as a vector in this format, in this bracket format. So it's going to equal 2. Yes, it's going to be negative. Yes, it's going to be 0 minus negative 1. So it's going to be 1. Next one is going to be cross this out. So now this one 0 times 0 minus 1 times 0 is going to be 0. And now the next one is this one. And now we have 0 times 1 minus 1 times 0. It's going to be 0 as well. Like that. And this is not equal to this. And this is not equal. So thus, this is false. Yeah, so the statement is false. I'll just put a, false right here. Yeah, I'll just, I moved it over here instead. So I just put a false over there. So this is false. Yeah, so it's not equal to it. Alright, and so thus the statement is false. Just type that out.